Question 9. Diagram below. This probably should start with this. We're halfway through now. The questions are going to get just a little bit harder, and this is probably an example of something that's a little bit trickier than what we've seen before. Okay, but we'll break it down, and it should become clear what's going on. Okay, I'm actually going to see if I can. Sorry, I'll just read the question. So in the diagram below, we've got ABE is a tangent to the circle. So this line here is a tangent. Okay, that's fine. I think we can see that quite clearly, so I'll just cancel it out. And they're telling us an angle as well. So again, we don't need anything from up here. Calculate CAB, a highlighted angle. Okay, so again, words, don't really need them. I'm going to see if we can zoom in. Does that work? Yeah. Okay. Just go down a tiny bit, maybe. Yeah, that's right. Okay. So this is basic. This is your standard angle chasing. Okay. Now there's a few rules that it's maybe worth writing down just outside of your page, just to remind you of what's going on. Okay. So we should remember that tangents meet radii at 90 degrees. Okay, so there's a wee 90 degrees in here and here. Okay, there's one. We should remember that isosceles triangles. These two lines are the same length, and these two angles are going to be the same. Okay, that's another good rule. And if we have a circle, and we've got our diameter, if we draw two lines from that diameter to the circumference, this angle in here is always 90 degrees. Okay, so if we've got a base is a diameter, and we've got two lines, that's always 90 degrees. Okay, so if I've got a diameter, two lines like this, that is still 90 degrees in there. Okay, that's 90 degrees all the way around. So as that triangle moves all the way around here, so that point moves, that angle still says 90. Okay, so these are the three big ones to bear in mind. Okay, obviously ones from before, from first year, is that in a straight line, two angles add up to 180 degrees. Okay, so this angle and this angle add up to 180. Angles around a circle, they're always going to add up to 360. Okay, so all these angles in here add up to 360. And you've got your F angles and your Z angles. Okay, but this question seems more concerned about the minute you see tangent, you should be thinking of the tangent rule. Okay. So first thing I would do, I'll use purple for this. I would highlight my right angles just because it even said it in the question. So as I read that in the question, I might think, right, well, I know that's 90, and I know that's 90. Okay, so right away, that's a good start. And I know this is 58. Okay, so I can now do something, can't I? I know that this angle here has to be 90, and I know part of it's 58, so the other part is going to be 32. Okay, so I've used my 90 degree rule. The next thing, I've got my circle, so I'll be thinking, well, obviously I'm just going to actually rub that out just now, and just keep 32 inches to keep it neat. Now the other thing I'll be thinking about is, what else have I got in here? Well, I've got my diameter, which is shown along here. And I've got two lines coming off the diameter, so actually, and you can see it does look like it as well, it's very visible once you spot it. Actually, not only is this angle 90 degrees, which we just said, because of a tangent, but this angle in here is 90 degrees. Yeah. So if this is 32 in here, then this is going to be 90 minus 32. So that's going to be 58. So that's quite interesting. Something quite beautiful about that, I don't know why. But yeah. So right away we found two angles without a huge amount of work. Okay, we've used this rule as well. Just going to rub out that because that's not a new rule. So I know that is 58, 32. Okay. Now, remember the 180 rule? This whole angle here is going to have to add up to 180, isn't it? So, what's 58 plus 50? 116. Yeah. Plus 32 is going to give me 148. So that means this angle in here is going to be 32. Okay. So there we go. I found another angle. and I've used these three rules. And the one rule I've not used, which is probably the most powerful rule, I would say, is the isosceles rule. And this is the thing that people struggle with. Okay, so this rule here. Now the two lines being the same length, how do we know which two lines are the same length in a circle are going to be radii? Okay, so finding your radii. Okay, so there's a radius, there's a radius, and there's a radius. So they're all the same length. Okay, so if they're all the same length, with this in orange, you can draw little lines, and the little lines are great because the little lines are actually like arrows where they point to the two angles that are then the same. Okay, and this one's pointing down here. So I know that's going to be 58 then, if that angle is 58. And if this is 32, I know this angle in here is going to be 32. Okay. Sorry, I just realised the only other rule I've not written down is a very obvious one as well. Angles inside a triangle add up to 180. Okay. Kind of going outside the box a bit with these. I've just noticed. Let me just rewrite them. Sorry about that. 180, 360, and 180. Okay. So if this angle is 32 and this is 32, that's 64. That would make this angle 116. Okay. Now again, we've got a straight line. So 180 minus 116 is going to give us 64 in here. And let's just check that. 64 plus 58 plus 58 should give us 180. So 58 times 2, that's 116 plus 64. Yep, cool, so I'm happy with that. So I've gone way beyond what you need to do so far. I've actually worked out every single angle. Okay, I've just been chasing around the angles, seeing what I can get. Okay, so I've got every single angle so far, and we're trying to make our way obviously to this unknown angle. Okay, the only other angle I've not worked out is this angle in here, and again I've got 58, so I could do the straight line rule, which is 122. Okay, so to get this angle in here, I just say, well, 180 degrees in a triangle, so 122 plus the 32 is going to give me 154. So it means that the angle in here is 180. This is going to be 180 minus 154. So that's going to give me 26 degrees. Okay. So that was me literally chasing every single angle on there. Now I'm just going to use the pink pen. Okay. So that was one way of doing it, was using the angles in this triangle. But you can actually make up other triangles as well. Some people, which is quite cool, can draw a straight line down here and say, well, I know that's 90 degrees because I'm going to draw that completely perpendicular. So what's the angle up here going to be? And then they make a triangle out of the 58 and the 90, yeah? And then they call this, one big triangle. That's one way of doing it, which is, I think, is a really interesting way. I never thought on that. Okay, the more obvious way which you could do it, apart from the method I've just done, which is kind of chase around all the angles and just see what you get, is to make a nice triangle. See here, so you've got 90 degrees in here, and we know this angle is 64, so therefore that's going to be 26. So actually, we only need to know our 94, which was the 90, which was from the tangent rule, and then work out what the 64 was to then get the final answer. Okay, so that's another nice way of doing it as well. But I do really enjoy those questions. I think they make you think a lot. But just fill in as many as you can. Okay, just write down your rules at the side. Okay, so we went through the tangent rule with the remember that these are radiuses. So for the isosceles triangles, find your isosceles triangles with the radiuses, and remember those little lines. That's why we draw them in to say they're the same length. They kind of point to the two angles are the same. Okay, so don't be confused. Some people confuse which angles are not the same. Okay, it's the ones on the outside the triangle, if you like, the ones that the wee lines point to. The wee lines is the technical term for those lines. But I really enjoy those questions. Great fun. Just take your time and just angle chase around. And again, if you double check, I was checking in here, saying, well, 116 and 64 should be 180. Does the 258 plus 64 give me 180 inside a triangle? You have a wee check to see if you think you're right. Okay. But loads of ways to do that, loads of ways to get into these triangles, but just start somewhere and work your way out and see what you can fill in. Okay. Let's see if I've got time to do another question. Possibly not. Change the subject. You know what? I'm just going to post this one. Okay, we'll move on to that one next. So that's question 9. Okay, thanks. Oh, sorry, the marking scheme. Oops, forgot the marking scheme. Oops. So you were getting a mark for OBD. So you're getting a mark for your 32. You were getting a mark for that doesn't look right. 32. Your mark for the 58, and then your final mark at 26. So it's quite a. I think it's just one of the ways to do it. It's quite odd. I think you would probably find you got. I'm not sure. I'm not a marker, so the marking scheme is a bit new to me. But certainly, you're getting a mark for your final answer. You're getting a mark for this first answer, and then maybe you would get a mark for something in. So you're getting a mark for something in the middle. Okay, so again, if you don't know the final answer, you're definitely getting something for 32, and you might get another mark for working out, isosceles triangle or something. Okay, that's the way I'm interpreting it. I might be wrong though.